Heat pump versus air conditioner. What's the real difference and which system is better for your home or building? In this video, we break down how heat pumps work compared to traditional air conditioning systems, including efficiency, cost, heating performance, and best applications. If you're trying to decide between a heat pump versus air conditioner, you're not alone. Although they look the same, install the same, and even cool the same. A heat pump heats and cools. An air conditioner only cools. But the real decision isn't just about the equipment. It's about how the building behaves, and most people, even in the industry, miss this. Let's break it down. How they work. Both systems use the same refrigeration cycle: compressor, condenser, expansion device, and evaporator. In cooling mode, they both remove heat from inside and reject it outside. Performance is nearly identical. A heat pump has a reversing valve that allows it to reverse refrigerant flow, pull heat from outside air, and deliver heat inside. Even when it's cold outside, there is still usable heat in the air. This is why heat pumps can heat without burning fuel. Air conditioner requires a furnace or electric heater for heating. Heat pump provides both heating and cooling. This is the biggest functional difference. Heat pumps can reach efficiencies of 200% to 400% in heating mode because they move heat rather than generate it. But that performance is highly dependent on outdoor air temperature. As temperatures drop, efficiency declines, and in colder climates, a high-efficiency gas furnace can outperform a heat pump in both capacity and reliability. This is why many systems use a dual-fuel setup: a heat pump for mild temperatures and a gas furnace for colder conditions. Heat pumps usually have higher upfront cost and possibly lower energy bills in mild climates. Air conditioner plus furnace are often lower first cost and can be cheaper operating where natural gas is inexpensive. The most missed fact. Now here's where most HVAC decisions go wrong. System selection should not be based on the building alone. It should consider zone loads. Interior zones in commercial buildings such as offices and large retail spaces require cooling all year due to people, lighting, and equipment loads. The key insight is that interior zones often do not require heating, even in winter. Best choice for interior zones: air conditioning systems, chilled water systems, or cooling-only VRF. Installing a heat pump here would add cost and complexity with little to no benefit. Now let's look at perimeter zones which have exterior walls and windows and possibly a roof directly above. These zones experience heat loss in winter, solar gain in summer, and a constant load swing. The best choice for exterior zones might be a heat pump, as you get heating and cooling in one system. It can handle seasonal changes and eliminates separate heating equipment. Real-world design strategy. In real projects, the best designs use a hybrid approach. Interior zones use cooling-only systems, and exterior zones can use heat pumps or systems with heating capabilities. Before selecting a system, always evaluate if space is an interior or exterior zone. Climate zone. Utility costs, electric versus gas. Building load profile. Installation budget. Energy code requirements. Owner goals, efficiency versus first cost. There is no one-size-fits-all answer. When to use each system. Choose a heat pump if you're conditioning exterior zones. You're in a mild or warm climate. You want all-electric systems. You need both heating and cooling. You're designing for decarbonization and electrification. Choose an air conditioner if the zone is interior and cooling dominant. Heating is not required. You want lower upfront cost, or a separate heating system already exists. Choose an air conditioner plus a furnace if you are in a cold climate and you already have a gas infrastructure. 3 key takeaways. 1. Heat pumps move heat, while AC units only remove it. That's the fundamental difference. 2. Interior zones often don't need heating, so don't pay for equipment you won't use. 3. The right system depends on the zone, not the building. Design based on actual loads, not assumptions. Heat pumps are highly efficient, but only when the outdoor conditions support it. If you want to understand HVAC systems the way real designers and estimators do, Check out our full training programs below. And subscribe because we break down real-world HVAC concepts that matter in the field. If you found this video helpful, be sure to check out our HVAC and plumbing estimating spreadsheets to streamline your construction bidding process. Check out our HVAC, electrical, and plumbing construction forms to help you run your business, and explore our online courses for in-depth training.